Hello, welcome back to this session on design of isolated footings, which is from our syllabus of design of concrete structures. So, I would like to tell a few introduction regarding this design. Uh, Isolated footing is a type of shallow footing. There are other types of shallow footings also. Three types of isolated footing are shown here. You can have a stepped footing, a sloped footing, or a simple footing. So simple footing is like a rectangular slab. Sloped footing, the top bottom is flat, but the top is sloping, like a truncated, say, pyramid. Then stepped footing will have integrally cast or monolithically cast slabs of various dimensions as seen. So we will be discussing about concrete footings, footings made of RCC. So you have studied some points regarding the design of footings, and not actually design of footing, but the geomechanics or geotechnical aspects of an isolated footing. So I think you must be knowing how to calculate the bearing capacity of soil from various properties of soil, and you should know that you should remember that shear failure of soil is very critical. So the bearing capacity is governed by shear failure shear failure criteria, and the next criteria in fixing the bearing capacity is the settlement. So we decide the bearing capacity based on shear failure capacity and settlement capacity. Various values of settlements on various types of soils you must have studied. These values may vary from 25 mm to say maybe 100 mm. So generally we may accept value of 25 mm or 50 mm as the case may be. So once in the numerical problem in design of concrete structure, you are given the value of mm, bearing capacity, then you should understand that all these things are underlying in that. So when we do the concrete design of an isolated footing, we need not to think about the shear failure of the soil or settlement of the soil. We need to use the bearing capacity as it is. And you know, bearing capacity is a is a type of pressure carrying capacity of soil. So our footing will be exerting a pressure on soil, and if that pressure is less than the bearing capacity of the soil, then our footing is safe. And also, you know that we will apply some factor safety for the bearing capacity value, which you must have studied in the geotechnical engineering class. So, in design of concrete structure class, the footing is designed, isolated footing is designed by knowing the bearing capacity. So this will be known to you. So based on the bearing capacity, we need to identify the plan dimension of the footing, because on the column some P kilonewton will be acting, which you may be getting based on the structural analysis. So, you must be familiar with structural analysis of simple portal frames and all. This is extended to building frames and all, and as a result, you will get force in each column, vertical force or axial force in each column, P. So the area of footing shall be such that the P divided by the area will be less than the safe bearing capacity of soil. So based on that, the first step we need to decide is the area of the footing, so that the pressure calculated at the base of footing is less than the bearing capacity of soil. So once you fix the area of an isolated rectangular footing, so there can be square footing or rectangular footing. There are other types of footing, but design is included only for square and rectangular footings. In square or rectangular footing, one column will be supported, and there are combined footing for which you don't have any design calculations right now in this semester. There, two, three, four, five columns may be, I mean, supported by the foundation. And other type of shallow foundation is a raft foundation, which is a bigger slab on which uh, many columns will be supported. But in our case, it is only one column, and the plan shape of footing is either square or rectangle. Okay. So for this slab, actually, see, we have studied the design of slab earlier. In that, we have stated that slab is capable of taking shear stresses because shear stress acting in slab is quite negligible when we studied slab because the action is of membrane action or diaphragm type of action. But that is possible if and only if the slabs are connected or supported over a grid of beams. When slabs are supported on beams and then these beams are supported by columns, then the slabs are okay in taking or in carrying shear. But here in the case of footing, the thing is just reverse. You can see that it's an inverted type of slab which you have studied. So here the slab is below and column is above, and there is no beam in between. Only column and slab, or only column and footing pad. You can call it as a footing pad. So this footing pad, since there are no beams or grid of beams, there is a possibility of punching shear failure. That is, the column may pierce into the slab or footing pad. So that is called a shear failure. So that is called a punching sort of shear failure. So that there are two types of shear failures possible in the slab. That is, the column as a whole may pierce or the into the slab, or the slab may shear as a, to, if you can see that if this is the slab, this slab may shear like this as two pieces, or otherwise it may, a column may pierce into this. So when a column is piercing, we call it as a two-way shear. So the sheared surface will be like a uh, periphery of a box. Okay, an open rectangular box or a open square box. So that is two-way shear, and one-way shear is the slab or footing pad is separated into two pieces. So failure is very important, or shear design criteria is very important in design of footing. So the first step will be to design the or the to decide the footing thickness based on the shear failure criteria. And the next action, structural action, since it is a slab, is nothing but our ordinary bending. So you know how to deal with bending moments in slabs and all. So you know how to calculate the thickness of slab based on this. Anyway, in isolated footings, generally, we experience says that we need to decide the depth based on punching shear or two-way shear or one-way shear. Automatically the thickness required for bending will be quite less than whatever we calculated the thickness based on shearing. So this is the introduction. And one more thing is that if you are given with the column reinforcement, generally footing is designed separately, column is designed separately. But if you have the column design values like reinforcement, etc., main reinforcement in the column, then you can check for the transfer of load from column to the footing pad. So for that, some development of length calculation, etc., is there, bond based calculation, etc., is there. So that also we will discuss, so that we can be comfortable with the transfer of loading from the column to the footing base. Okay, so with that introduction, let us do a numerical problem. And as I told you, we have only two types of problem, that is a square footing and a rectangular footing, which is a simple slab like footing pad. Okay, thank you for the time being.